Alright, you guys, so we're going to pick up with finishing example 3. This is by far the most involved example, and I just want to point out that the directions in general for our examples thus far have all been pretty much the same. We're supposed to be able to graph a quadratic function, and so the methods I've been teaching you are methods that you can choose between. Like in your classwork today, you're going to be asked to identify the vertex of a quadratic when it's in standard form. So example 1 had you do that by putting it by changing it from standard form to vertex form. So you could see what the vertex was, HK. However, example 2, let's see, in example 2, we didn't have to complete the square. We had to, we used the vertex formulas where we were able to calculate HK, okay? So you have different options. You don't have to do something that you don't particularly like. If there's a preference that you have, then feel free to go ahead and use that, okay? So we're picking up with number 3. We're finishing up, really. We're picking up with number 3 by finding the x-intercepts. We calculated a discriminant and saw that we had 2 x-intercepts. So I'm going to go ahead and I'm going to review the quadratic formula. Alright, because we're going to use the quadratic formula for this. The reason that the quadratic formula is so nice is because it helps us find the solutions to quadratic equations that are not factorable, okay? And so the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. All right, that should look familiar. We just used that. That's the discriminant expression over 2a. Okay, and so what I'm going to do is I'm going to plug in. I have, remember, a is still equal to negative 2. All right, b is still equal to 4. And c is still equal to 2. Okay, I'm also going to put in the discriminant is equal to 32. Because remember, this is our discriminant expression. We've already calculated it, so we can just throw that in here in a second. Okay, so I'm going to go ahead and we're going to use the quadratic formula. So I have negative 4, so that's negative b plus or minus the square root, the discriminant expression b squared minus 4ac we already calculated and had it's 32, and that's all over 2a, so 2 times a negative 2. Okay, so that's the quadratic formula. We have negative 4 plus or minus the square root of 32 over 2 times negative 2. Now I have kind of run out of room. Let's see if I can find some space. I'm going to come up here to my objective just to finish up. So here's what I have. I have negative 4 plus or minus the square root of 32 over 2 times negative 2, which is negative 4. Okay, so real quickly, I'm going to simplify a radical. We can review this real quickly. Alright, my prime numbers, I'm dividing 32 by 2. 2 is prime, so I'm circling it. Divided by 2 is 4, divided by 2 is 2. Okay, so again, we've done this before. So the square root of 32 is equal to the square root of, I got 5 2's here. Okay. So I have a pair of 2's, a pair of 2's. So I have, this gets to come out front, this gets to come out front. So 2 times 2. All right, this guy is by itself because it wasn't part of a pair. So 2 times 2 is 4. 4 square root of 2. All right, so I'm going to rewrite this, this solution here. All right, negative 4 plus or minus 4 square root of 2 over negative 4. Okay, so I'm going to be able to simplify this a little bit. Okay, so I have negative 4 divided by negative 4. That's dividing these right here. Negative 4 divided by 4. So that's just 1. And then I have plus or minus, and then I have 4 divided by negative 4, okay, square root of 2. All right, so I have 1 plus square root of 2, 1 minus square root of 2, okay. Now this right here, these are my two x-intercepts, 1 plus square root of 2, 1 minus square root of 2. So I'm going to come back down here where it has some room, and I'm going to write that. Write that here. Okay, so I have 1 plus the square root of 2, which you can type in your calculator. 1 plus the square root of 2 is 2.41 if we round to the nearest hundred. And then we have 1 minus square root of 2. And if you type that in, you get negative 0.41. Okay, so those are our x-intercepts. I'm sorry to kind of squeeze them in here, but these are our x-intercepts. Okay, all right, so we have lots of points here. All right, first of all, I have my vertex. So vertex is at 1, 4. All right, so I'm going to come down here and I'm going to plot the ordered pair 1, 4. Okay, then I have a y-intercept at 0, 2. Okay, y-intercept at 0, 2. So y-intercept is at positive 2 on the y-axis. Okay, what else? I know that I have an axis of symmetry at x equals 1, since that's the x value of my vertex. So if this is my vertex, and this quadratic is symmetric about the vertex, then if I have a y-coordinate of 2 and x is 0, I also have a y-coordinate of 2 when x is 2. So that's 1 to the left from my axis of symmetry and 1 to the right. Okay, and then I have my x-intercepts, which I just found using the quadratic formula. Okay, so I had negative 2.41, which, I'm sorry, negative 0.41, so not quite halfway between 0 and negative 1. And then I have positive 2.41, so 2.41 is not quite halfway between 2 and 3. Okay, so you can see that that's symmetric about its axis as well. All right, so these are enough points to plot this. This is my vertex, and I did my best to show going through the lines. Through the points. But here's my quadratic graph. Like I said earlier, you guys please graph that neater than I did. So that is there. Okay. We were asked to find a little bit of information about this. You guys, if you want to make sure that you write in pencil, it asks you to find the domain, the range, where it's increasing, and where it's decreasing. All right, so you guys, if you'll do that in interval notation, I'm going to go ahead and finish up example 4 just in the interest of time. If I have time within the 15 minutes, we're looking at about 5.5 more minutes. So if I have time, I'll come back, and if I don't, that's something that we've gone over before. So hopefully you should be able to get that, and we'll review it next class. All right, so final example number 4, we're asked to graph this. You guys, this example is not going to take nearly as long as example 3 did. I'm going to use just some traits about the quadratic. So we're going to first calculate its vertex. Okay, so this one, I'll go ahead and list A is just 1 here. I have B is -6, and I have C is 9. Okay, and so we're going to go ahead and calculate the vertex. Alright, so for our vertex, the x-coordinate is -b over 2a. So -6 over 2 times 1. So -6 is +6 divided by 2 times 1 is 2. Alright, 6 divided by 2 is 3. So that's the x-coordinate. Alright, our excuse me. So our y-coordinate of our vertex, the y-coordinate is going to be when I evaluate the function when x is 3. That's the x value of our vertex. So I'm going to plug that into our function. I have x squared, so 3 squared minus 6 times 3 plus 9. 3 squared is 9. -6 times 3 is -18 plus 9. Okay, so I have 9 minus 18 is -9 plus 9 is 0. Okay, so the y-coordinate is 0. So that means that my vertex is 3, 0. Okay, so 3, 0. I could go ahead, let's go ahead and we can graph that. Alright, so 3, 0. Alright. Okay, so we have the x-coordinate and the y-coordinate vertex. Okay, I know that my axis of symmetry, axis of symmetry is going to be x equals the x value of my vertex is 3. So I can come down here and I can do a quick axis of symmetry. Sorry about my dotted line. Alright, there's my axis of symmetry. Okay, I know that this is going to open upward, okay, because the a value is 1. So here's another quick fact. So a equals 1. 1 is greater than 0. So it opens up. Okay, that's another characteristic. Let's see. We can get our y-intercept. So for y-intercept, I can do 0 in place of x. Okay, so my y-intercept is going to be the function evaluated at 0 for x is equal to 0 squared minus 6 times 0 plus 9. Alright, 0 squared is 0, minus 6 times 0, that's minus 0 plus 9 is 9. Okay, so my y-intercept is 0, 9. Okay, I can go ahead and plot that. 0, 9. Okay, now you guys here, the vertex is on the x-axis, so that means that it just touches the x-axis once. Now I can use my line of symmetry. This y-coordinate of 9 is 3 units away from the axis of symmetry. So I can go 3 units away in the other direction, 1, 2, 3, and that puts me a point there, okay? So I have my y-intercept at 0, 9. I have an axis of symmetry, and I have my vertex. So really, that shows all I need. I have a vertex here. It needs to go through the points, the 2 points here, the y-intercept, and then the point that's 3 units away from the axis in the other direction, okay? So that's the graph for this. You guys, here again, we're asked to find the domain, the range, where it's increasing, where it's decreasing. So all this belongs in interval notation. That's